Actually, you already know. There are already a large number of large language models on the market, each with its own focus and specialties. It seems that you have a lot of choices, but after choosing, you may find that no large language model product on the market can meet all your requirements. Take me for example, I have a lot of data stored on my local computer. They are PDF, Word, Excel, and Markdown notes recorded with LogSec. I hope that LLM can know the content of these materials and cite them during the conversation with me. In addition, I also hope that the materials cited by LLM are relatively credible. For example, it should cite papers in journals or at least searched from Wikipedia. Don't just cite the top-ranked web pages found on Google. In fact, if LLM does not rely on any reference materials and only relies on its own trained model, the materials it gives may have hallucination problems. Maybe you will say that the LLM products on the market are rich enough to meet all the requirements you just mentioned. Well, but these products always fall short in various details. For example, I don't want to upload my PDF files with hundreds of pages to their servers one by one. However, wouldn't it be cool if I could build a LLM process designed entirely by myself on my laptop? All the details are decided by me, and I can completely customize this process according to the requirements of my work. This is something that the LLM products on the market cannot provide. To do this, you need LangChain. LangChain abstracts the steps of LLM problem solving into multiple concepts. Each concept corresponds to the steps to solve a specific problem. These steps are connected, like a chain, to become a complete LLM solution customized for you. More importantly, LangChain allows you to choose different LLM products for each step. For example, I will use a small LLM model that can run locally to screen out the text that meets the requirements from hundreds of pages of PDF. This small LLM has weak problem-solving capabilities and looks a bit stupid, but I don't have to pay for it. Then in the next step, I will splice the screened content together and hand it over to the relatively powerful but more expensive ChatGPT-4 for processing. With LangChain, this is easy to achieve. In this video, I will show you how I use LangChain to build a customized LLM solution. I use OOMOL to build it, which comes with some of the most basic LangChain components. First, let's create a project and name it my LangChain. So this is an empty flow panel. There is nothing here. We can drag some pre-made LangChain components to this flow. Let me think about it. Let's drag a prompt template on it. All LLM interactions start with a prompt. Think about it. A typical scenario for interacting with LLM is this. We humans describe the problem in natural language. The text of this problem is a prompt. AI receives this question, which is a prompt, and then uses a text to answer it. Now, I want to build a template for this prompt. Here, I tell AI who you are and what you want to do. But note that I did not write my question directly. Instead, I used two curly braces to wrap a word, question. This is because this is not a real prompt, but just a prompt template. When LangChain is actually executed, it will get the question raised by the user, replace it with the part wrapped in two curly braces in the template text, and then pass it to AI as a real prompt. Okay, next, I have to decide which AI will handle our prompt. As we know, LangChain supports many LLM manufacturers. Here, I use OpenAI as the AI to handle prompt. Here, select which model of OpenAI you want to see. Let's use GPT 3.5 Turbo here. Next, we have to select the API key. It can be created and found on the OpenAI website. I won't demonstrate it here. I assume you know how to get the API key, so how do you set it to the panel? We need to create an OpenAI in this OOMOL secret panel and give it a random name. Hand copy and paste the API key here and you're done. After that, you can find the API key you just created here and select it. The other options are configurations related to OpenAI, and we don't care about them here, just keep them at the default values. Then, connect the prompt template created earlier to the OpenAI model. Next, OpenAI will return the process prompt text information to us, and we need to decide how to display this information. Here, for simplicity, we let it return text directly. Drag text output and connect it. In LangChain, these connected things are called chain. Before we really interact with AI, we need to build chain and call it to realize the real interaction with AI. Here, we create and invoke chain block as a conclusion. Such a chain connected from beginning to end is constructed, which is the origin of the name LangChain. Finally, we need to use a block to display the output result after the call. We previously stipulated that AI should output in the form of text. Usually, OpenAI organizes text in the form of Markdown. We can connect a Markdown previewer at the end so that we can see the runtime results directly on the flow panel. This step is not necessary. If you do not accept the preview, you can also view the results in the log. However, wouldn't it be better to display the results more intuitively on the panel? In this way, we have built a real LangChain. From the preset prompt template, we can see that this is a LangChain that solves user questions. However, it is not really running yet. It still needs the user to enter parameters before it starts to answer questions. The question will be input to the invoke chain block as the params field. By definition, this params must be a key value pair. If you are familiar with Python programming, you should know the dictionary type. It can store multiple items, each of which consists of a key and a value. Now, we need to express the dictionary in Python code. Here, you may need to know some Python programming. In fact, if you want to be proficient in using LangChain, you can't escape writing code in Python. Here, we drag in the Python block. In this way, there is a code editor in which we can write Python code. This code will call the main function, and its return value should construct the dictionary object we need. This code outputs a field called out, which corresponds to here on the panel. I want the type of this out to be compatible with dictionary, so I change it to any, then connect it to the params field of invoke chain. In addition, for this Python code, input is useless, so I delete this in field. Next, let's look at the prompt template we wrote earlier, where we wrapped the word question with curly braces. I hope to replace the question wrapped in curly braces with the user's real question. So, in the code, we define a dictionary with only one key called question, and fill in the question the user wants to ask as the value of this key. Then return it as the out field. This out field, we have already connected it to the params field of invoke chain block. The dictionary object we built with Python code will also be executed as a parameter of the entire chain at runtime. Finally, the entire LangChain has been defined. Let's click here to run it. Okay, here you can see the AI's answer to our question. I dragged it over here and put it together with the question. This is the question asked by the user. Introduce Freud of Austria. This is the introduction given by AI, which introduces Freud's identity and achievements. The text is given by the OpenAI big model we configured here. It will use the API key I filled in here and deduct money from the credit card bound to this key as the fee for this call. This is the entire LangChain we just built. The tool used this time is called OOMOL, which comes with a container environment. If you have heard of Docker, you should know something about containers. This is a lightweight virtual machine that can quickly deploy the operating environment and development environment required by LangChain to my machine. Therefore, I omitted the installation and environment configuration steps of LangChain in this video, because OOMOL has already prepared everything for me through the virtual environment. If you want to build a LangChain environment without OOMOL, you need to prepare a Python environment on your own device and have a code editor. I recommend VS Code. Of course, these preparations may be a little complicated, so I won't introduce them in this video. In fact, I hope this video can be used as a LangChain quick start video. It would be better if everyone can quickly get started to build a LangChain and run it. After that, I will continue to share some scenes I built with LangChain, and I will also make videos. Thank you for watching this video, and see you next time.